Hello, and welcome to Physics for Dummies. I'm the dummy, and this is my attempt at physics. So, today we are going over momentum and energy. So, momentum and energy are pretty fun because it's pretty easy to connect them, and this is what I've learned from the FRQ last class that we had with Watley. So, momentum is actually momentum because I don't know why we made it momentum, but it is. So we have P equals M, which is mass, V, which is velocity. So P equals mv. And if you're recording impulse, it would be P equals m times the change in velocity. But that is a completely different story. So basically, energy, there are 4 equations that you need to know. So basically, there's potential energy, and then there's kinetic energy. But then there's spring energy, which is kx squared. That's the equation for spring. And x is the spring displacement. And k is the spring constant. And then for kinetic energy, that is half mv squared. And then potential is mgh, which is mass times gravity times height. So basically the weight times the height. So basically, with these problems, momentum is normally conserved in a closed system. So you're going to see a lot of like object A and object B, and you're going to have a lot of collisions. There's inelastic, elastic, and perfectly inelastic. So it'll either stick, bounce, or collide. So normally, when you're having collisions, there is energy. You always have energy. And so an example of College Board, they would love to do this to you, is they're going to, for my first example problem, after I erase this, so we're gonna put block A on this beautiful 30-degree incline, and block A is going to be 2 kilograms, and the length is 2 meters. So we're gonna crash into block B here. This is my beautiful little visual. Block B is 3 kilograms and it is currently at rest. So what is the speed of the blocks? We are looking for velocity. You know, with momentum, if something is less mass, it's going to have more velocity, meaning that it's going to have more energy because velocity is squared in the energy equation. But if something is heavier, it's going to have a smaller velocity, meaning it's going to have a smaller energy. So comparing the two of the objects is how you can find a lot of the variables. They share velocity and mass for different types of energy. So you know, at the top of the ramp, we are going to start with the UGH. So, you know, the potential energy is going to equal the kinetic. And then we're going to have the mass of block A times the velocity of block A equals the mass of block B times the velocity of block B plus the mass. So basically, sorry for the long explanation, but you're going to have to find the velocity of block A first, which you're going to do through the very complicated sign equations, which, you know, we'll get to those in a second. But all you need to know is that it's 4.4. So since we're using momentum now, we use energy to get our velocity because those two variables are in common. And then we're going to move on to MA VA plus MB V initial B equals MA plus MB, because they're going to stick together, times the final velocity. So then you're going to, in order to get this by itself, you're going to divide this by mass A plus mass B. And then you're going to get a beautiful velocity of 1.8. And that is how you do that problem. So basically, there was another problem before this, but you know, I don't know how much we're actually checking this. But let's find it. Am I missing anything from this video? Okay, yes, we have an that utilize both of the units. Perfect. So we're on the last practice problem. Thank God. You're probably very tired of me speaking right now. But it's basically, we're looking at the displacement of a spring. So we're gonna have this beautiful block A, and block B is going to move this way. And we're gonna push this into our little spring wall right here. And we're gonna look for this displacement. So in order to do this, you're going to use the equation kx squared equals the kinetic. And so in order to find, since this is a closed system and they're gonna go together, you're going to use the momentum. And that's pretty much it for this review. You can put them together, they have a lot of the same variables. And yeah, happy physics for dummies with your dummy and my attempt at physics.